All right, hello everybody. This is Miss Piekarski. This is the first video about rational functions, and on this page you just have the two examples of your rational parent functions. The first one is just 1 over x, and it looks like this. You have a curve that goes right here and a curve that goes right here. These red dotted lines are not part of the graph. These are just showing where the asymptotes are. We've kind of covered asymptotes a little bit already. Most of you know that's a line that your graph does not cross. So we have, with rational functions, you have vertical asymptotes and you also have horizontal asymptotes. Now, this graph here is 1 over x squared, and anytime you have x squared, you've got both of the curves are going to be on the same side of the x-axis. Okay. Most of this stuff you've seen already before in our unit on transformations. With the domain, domain is all possible x values. Now, wherever the asymptote is, that is not part of the domain. So in this case, the domain is going to be from negative infinity to 0 because our asymptote is there, and then 0 to positive infinity here. Now, the domain for both of the parent functions is exactly the same. Okay, they both have a vertical asymptote at 0. Now on the range, same thing as the domain over here. You're going to go, all possible y values will go from negative infinity. You have an asymptote at 0, and then on up to positive infinity. So in this case, your domain and range is the same, but over here, it is slightly different, and I think I have a typo here. I sure do. This should be a parentheses, not a bracket, because of the asymptote that's right there. Okay, so when you're filling this page of your notes out, make sure you have a parentheses here. Also, if you have a red pen or a marker, go ahead and do dotted lines for your asymptotes there and there. All right, let's go on to the location of a vertical asymptote and horizontal asymptote. Your vertical asymptote is going to be vertical like this, and the way you describe it is what the x value is. So the x value right here is going to be 0. So you're going to say that your vertical asymptote is at x equals 0. Okay, same thing over here. You're going to still have the same vertical asymptote, but x equals 0 because this is where a vertical asymptote is. Horizontal asymptotes go horizontally. Okay. In this case, to describe that, you tell what the y value is, okay? And so in this case, our horizontal asymptotes are at y equals 0 for both cases. Hopefully you remember all this stuff from transformations. You do need to have it down here again. And let's just go through some of our transformation notes really quickly. You'll notice that your a value is with the rational function is going to be in the numerator. So notice my blue graph has an a value of 1. So that's the standard form in both of these. This is where the original parent function is. If your a value is greater than 1, let's say it's 5, notice these points, the dots here and here, they get farther apart the bigger your number gets here. Okay, now you can't just draw a line between these two and say the distance is 5. Okay, it's not always going to be the case. For example, you can't draw a dot or a line from this dot to this dot and say the distance is 1 because your a value is 1. It's not going to work that way. However, you can see that as your numerator gets bigger, these kind of key points where the curves go a vertex, I guess, is what you describe this as. These would get farther apart, okay, as this number gets bigger. Also, if it's a negative, you reflect across the axis, so the black lines are the negative sign. Okay, so if as a increases, your points get farther apart. Okay, if it's negative, it reflects over the horizontal asymptote. All right, sorry guys. next page. We're almost done with the video. Here's a lot of graphs. We just need to describe H and K. Now, in these notes, we use the letters H and K. When we are doing our transformation units, we use the letters D and C. Let's see. So H is just like the C value in your transformations, and K is just like your D values in your transformations. Honestly, it really doesn't matter what variables you use here and here as long as you check the location. So if you have a number, like in this case we have 1 divided by x minus 4, you're just going to take the whole graph and move it to the positive side of the x-axis 4 units. Okay. If you have 1 divided by x plus 6, you're moving it to the left side. Okay. Notice the difference on if we're adding on the outside out here. We're moving up and down. If we're adding 6 at the end, we're moving up. If we're subtracting 4 at the end, we're moving down 4. Also be aware that this value here and this value here tell you where your vertical and horizontal asymptotes are. Okay. So in this case, when we're doing the horizontal shift, we moved that vertical asymptote from 0 over to -4, or over to +4 here. When we have an x plus 6, we're moving the vertical asymptote from 0 on over to +6. Okay, in both cases, and it doesn't matter which parent function you're starting with, if it's squared or not squared. Okay, it does the same type of transformation. Okay, when you have an equation in this format, that's called the transformation form of your rational functions. But unfortunately, most of this unit, this is the type of rational functions we're going to be dealing with. Okay, notice you can't just say, hey, my A value is 1 or 2 or whatever. Okay, these get really, really crazy types of equations. And you don't have, a number out here saying, hey, we're moving it up or we're moving it down. Okay, so the biggest thing, make sure you understand these transformations, but know that most of our rational function problems that we're going to look at will look super crazy equations like this. And even though our standard parent functions, let me go back, even though this is the standard parent function here, we have a lot of different options on what a rational function can look like. I believe this is a page in your notes somewhere. Let me get rid of this, okay? This is just possible rational graphs. So it says here, suppose you have a rational function that has a horizontal asymptote at y equals 0 and a vertical asymptotes at -3 and 2. What are some possible graphs of the function? Okay, just with those 3 asymptotes, we have 6 different possible outcomes. Okay, so you can't just look at where the asymptotes are and say, hey, I know exactly what the graph looks like, because there's all these possible outcomes. Okay, and we're going to be looking at a lot of different equations that will have graphs that look like all of these. Okay, and then to make matters even more complicated, we can also have, let me back up a little bit. So these graphs are when we have vertical asymptotes and horizontal asymptotes, but we can also have what's called slant or oblique asymptotes. Slant and oblique are 2 synonyms. They mean exactly the same. It just depends on which math class you're taking, whether it's in high school or in college, and what part of the country you are taking your class in. So some places they call it slant. They also call it diagonal asymptotes or oblique asymptotes. So you'll hear all of those words. You might want to write them down. Let me see if I can remember how to spell oblique. Oblique, O-B-L-I-Q-U-E, I believe, or diagonal, I-A-L. Okay, if I misspell that, let me know tomorrow, okay? You guys know me. I'm a great math teacher. I'm an absolute horrible spelling teacher. Okay, so slant asymptotes can be just another words for slant asymptotes are oblique or diagonal. Okay, anyway, so if you had a graph where you have a rational function that has a vertical asymptote at x equals 1 and a slant asymptote given by the equation y equals x minus 1, sketch possible graphs of the function. Okay, again, with just this little amount of information, we have 4 different possible options, and they are all just slightly different. However, there is this option here has the same type of asymptotes, but notice that your graphs, whoops, ow, that hurt my ear. Let me change my pen color. No, I don't want black. Let's do green. You like green? All right, so suppose your graphs, this is the example that's in here. You have one part of your rational function that goes like this and another part that goes like this. In this case, this is not possible because it does not pass the vertical line test. Remember, if you drew a line vertically and you intersect the graph more than one place, it's not a function. Okay, so this is not a possible function, or this is not a possible rational function because it doesn't pass the vertical line test. All right, so I'm done with this video. I will be posting some more videos on the different types of asymptotes and how to find them when we have super crazy equations like this one. Okay, there's several different rules and ways to determine what type of asymptote you're going to have, and in the next video I will go over those asymptotes and the rules. Okay.